Alright, this will be a video for the project part, um, the Dolly body. So I have this, the final CAD model here. That will be our this part, and we do have one slides for the details how to make this part. Okay, so we have some pictures on the web course, so you can use them in your report. So that's just some different views of this assembly, also some parts. Alright, so let's look at this this model. So basically what we did is I revolved uh, the dome shape portion, then extruded and intersect, so we got this. And after this, it's pretty thick in the middle. Next, we use a shell command to make the flange on the side. Okay, those flange. So after the shell, that's the tricky part. I used a lot of edge blend to make it smooth. So the real part, if you look at the photo, is actually a sheet metal and stamped. Then after that, they put some rubber on top of this, on the surface. So that's why this is really rounded up and has different thickness. So I imagine inside the metal part is actually uniform. Anyway, so we just gonna model this as a whole piece without the rubber and the metal distinguished. So the tricky part of this model is really the edge blend. Okay, let's start the model. Okay, then close this first. Now, as usual, you want to create a new file at inch. Okay, modeling, and find a place where you can save. Name your model better. Okay, first is the revolve. So that's the sketch. I believe you don't have this grid line here. It will be much a little bit clearer to see. So again, we're gonna assume that z is the thickness direction. So for this sketch, we will create this on zx or zy plane. So here I'm just gonna create this on zy plane. Okay. Now we're going to create this geometry. So if you look at this, we have some uniform thickness here, which is 0.15 inch. Then for this top part, it will be thicker, which is 0.4625, uniformly from here all the way to the center axis. And it's raining pretty hard outside. And alright, you will hear some sounders. Welcome to Florida, right? Let's start from the bottom first. Okay, so the bottom is consisted from of 3 lines, one of which is an arc. So we can start from actually the this side, then go up. Then for the last section, that's an arc. So we'll use a 3-point arc. Actually, it should be start point, then end point somewhere here, middle point. Okay, then dimensions. Total length from left to right is 4 inch. So from this point to the vertical axis is 4 inch. And since we drew this thing out of scale, so you probably need to drag things around to make it up to scale. Okay, and then we need some basic constraints for this. as you can see from here, the button should sit on x-axis. So geometric constraint collinear for this line and the x-axis. Then for this point should be on the vertical axis. So we will need point on curve for this point, which I picked as the center of this arc. So I don't need that. Let's clear this and pick this point, the end point, to be on vertical axis. Okay, and if you notice here, there's a vertical, I'm sorry, that's a perpendicular constraint for this arc to the vertical axis. Why do we need this? After you rotate, right, the cross section would be a whole arc that goes from left to right with the vertical axis in the middle. So your axis, if your center of arc is on the vertical axis, the vertical axis will definitely be perpendicular to the arc at this point. If not, you probably have a sharp cone-like shape in the middle. You want a smooth sphere-like surface. So you want to put a vertical and perpendicular constraint for the arc to the vertical axis. Now dimensions. From the center to this point is, I think that's 1.9297. Okay. Then that's 1.9297. Then for this point to this, okay, we need to pick the point to the vertical axis will be 1.4078. Then now let's deal with the vertical dimensions. So from x-axis to this point, we need to pick that point. Okay, that will be right here, point 6264. And from the vertical axis, horizontal axis to this point, the end of this arc, that would be point 9125. Okay, now this line is green, that means this one is fully constrained. Okay, now for this, the top horizontal line, we can use a offset, or well, maybe offset is too complicated. We can just go straight up, 0.15 inch, hit enter, and click. Now we can go from, just drop it somewhere here, that'll be enough. And for this part, you know, it's a uniform thickness, which means this is a uniform offset. So we can use this offset command, type in the distance, which is here, P169 equals to 0.4625, hit enter, and pick curve. Okay, and be careful of the curve rule here. It's probably on tangent curve or connected curve, since you just want those two. So I'll use single curve, pick the arc, pick this line. Okay, and let's click OK. Now as the arrow indicates, the end point of the top arc is still on the vertical axis, so we're good on this side. Now, however, on this side we need a fillet, and also here. So let's add the fillet, which is 1 inch for this side and that's also 1 inch. So we can type in the radius first and hit enter, pick the 2 lines and click on the correct position. That's the first, then that's the second. Okay, that's the dimensions, and it's fully constrained. And now we are ready to revolve this sketch. So either you can finish sketch and then revolve. Since we're going to revolve this whole sketch, I'll just go for the revolve command right away within the sketch. So define the axis. It knows it's the Y, or because I left it there, you can default would be inferred. I'll pick the Z axis, so you don't need to specify the point. Okay, if you click here, it's actually parallel to the axis, but the position is not defined, which is the point. Okay, so we have this rotation here. You can finish sketch, and the second sketch would be this for the extrude, and later on we will do a intersection. Okay, let's build a second sketch, which should be on XY plane, perpendicular to your revolve cross section. Okay, that's our sketch. You can hide the revolve. Okay, also the first sketch. Alright, so for this sketch, you can see the holes. They sit on the a bigger circle, and let's start making the holes first. Because basically, once you have those 3 points, you have this circle on the edge of this body. Okay, so circle first. That's the reference circle, which is 5.5 inches in diameter, and the second reference circle would be this, where the this arc will be tangent on the circle. So this is 3 inches in diameter. Now we can turn them into reference. Okay, convert to reference, and next is the we can add those 120-degree apart construction lines or reference lines. So let's go from here to here. That's 1, and here you can just drop them at random place. Of course, you can do something like pattern. Okay, you can make this and a pattern, circular pattern for the 3 part. Anyway, turn them to reference, and I'll add dimension for those. That'll be 120 degrees, and the other side it's also 120. Okay, now we have the foundation. We can start building the actual geometry or the active curves. So the circle, you want to snap to the end point of this line, and 1/4 inch in diameter. Okay, and actually we can put those circles around the place. Okay, 3 circles. Then the bigger one, that's the diameter of 1.875. Okay, then we can click here also. Then for the lower right corner. Okay, so that's the 3 corners. Then the arc. Okay, that will be 3-point arc. So this arc actually has 3 contact points. First is from this side, and the end point would be on this arc, and in the middle it will be tangent to this reference circle. And as you can see, it's not tangent right now, but don't worry, we can add constraints later. Okay, and that's fine also. We can always add constraints later. Okay, now they're in place. We can pick constraint, or there's a faster way. First, let's turn off the arc center snap. So now I'm gonna pick the arc and this arc. That's tangent constraint. That's the pop-up menu for those. And we'll click this two, tangent, that two, tangent. This should be a little bit faster than you use the command. Oops. So it's already tangent here, that's why there's no tangent constraint show. So arc, circle, tangent, arc, circle, tangent. Here are the same. And while I'm doing this, you can enjoy the thunder of Florida. And this is done. Then we can trim this line off. So when you trim this line, it's actually pretty tricky. Okay, look, trim this, trim that. You see how this corner has this hollow point? That's not coincident, right? If it's coincident, it will be a solid blue dot. So if you zoom in here, actually we didn't cut all the way to the tangent point because we have this construction of reference circle here. So that's the not tricky, but it's just you have to be careful. You have to zoom in, cut that off, zoom out, and zoom in. Of course, you can pan also. So trim those off, trim the small section off too. Now we're good. That's all solid dots, and the sketch is fully constrained. If you want to, you can drag the dimensions back. And notice there's also a hole in the center. So that will be 0.5 in diameter. Alright, now we're done for this sketch and a finished sketch. Okay, and we can have a look at the revolve we just made. So the third slide is actually revolve that sketch. And then now we can extrude this what do you call that? Sketch. I'm sorry. Because when I made this, I drew the holes to at the end of this model. So probably you can extrude everything right now, but I'll just extrude the outside first. Okay. Don't have to have a definite, a specific distance, as long as this is higher than your revolve. And it's not unite here, you want intersection. You can show results. That should be the volume you want, and click OK. Alright, now that will be the geometry we want. So next is the shell to make the flanges around those three flanges, and the shell command. Now the thickness is the thickness of your flange, so it will be 0.15 inch, and you need to hit enter to make this effective. Then you can click on this big sphere face. Okay, that should bring us to the sharp corner version of the final geometry. Next slides. So here, as you can see, the order is pretty important for the edge blend. If you try to edge blend the second one first, it's probably gonna have some errors because this edge here, okay, in the model, let's take a look. Now the second edge blend goes along this edge, right? You have some sharp corner here and here. If I didn't do this edge blend first, then you would have error on this edge blend because of the sharp corner. I don't know why, but it's just the internal, when the software trying to find an edge blend surface for this geometry, it just couldn't find it. So maybe sometimes you have to try a couple times to find the right order for something like this. So let's go for the first edge blend is 0.5 inch, and for these three edges, okay, and now we got a smoother edge here. We can proceed to the second one, which is 0.1 inch, and hit enter. Click, and as you can see, it only picks up this much. You have to pick, and don't worry about the alert. Once you pick the whole edge, it will be fine. Let's try connected curve. Okay, that's not good. So I'm just go back to tangent curve and pick them up. Or yep. Sometimes you can turn this to wireframe. Might be easier to pick the edge and change our background to a darker color, so you can see clearly where your edge is. Okay, that's the edge, this and this. Okay, so we have picked up three edges. You can turn that back to shaded view. So that's the second edge blend. Okay, now the third would be this top. Okay, so edge blend. So after this, the video is gonna be pretty boring. It's always edge blend. However, for the sixth, which is which one? The last one. Maybe I can do this first, so you can skip the video. Okay, the only thing that's really out of ordinary, let me hide the sketch, is this the variable radius edge blend. So why do we need that? Because if you look at this or the photo, I don't know if I have that photo on, or this photo, this side. This actually, that's a very big radius compared to the radius here. However, in our model, okay, that's one edge, and you want this to be continuous and smooth. You can't just simply edge blend this one to be a bigger edge and a bigger radius, then edge blend that. Then you have a transition in the middle. So that's where the variable radius edge blend come in. So first you want to pick the edge. So let's pick the all the edge around this model at the bottom. Okay, now let's see. Okay, and you want to change the radius to the smaller one, 0.07 first, 0.75 first, and hit enter. So now it's 0.075 everywhere. I'm sorry, before that we need to make it smooth here. Well, just bear with me. Have to go all the way from here then. Okay, number 4 will be this 1 inch. Apply. The number 5 is 0.5 inch. 2, 3.5. Hit enter. Apply. Then number 6 is top again. As you can see, that's 0.15 divided by 2. Actually, 0.15 is thickness of this side. Also the thickness of the flange. And divide by 2 is because you want this to be around 180-degree arc. So pick this. Okay, that's pretty good. And it's running. Then also, I do want those to be in the same edge blend. Guess it didn't register. So actually that's 0.75, which is a half of 0.15. And pick this edge. Also pick this edge. These 3 edges for the flanges. And apply. Now if you look at the geometry, it's pretty good on the top. Let's go to the bottom. That's the only sharp corner left, and that's the also the rare edge blend that we're using here. So first 0.075 and hit enter, make it effective. Pick the edge. Okay, and luckily it picked everything. So variable radius. We have 6 locations. That's the smaller one. Has a smaller radius, which will constrain this 3 corners to be in the smaller radius. And we have 3 locations that we need a bigger radius. So first, let's pick the 3 smaller location, which is the end point of this arc, or the start point of this. So we can, in the snap toolbar, you can turn off the center of the arc, so you don't pick up the center of that. You can turn off the midpoint for now. Now we can pick end point of this and end point of. Well, I was meant to pick the end point of the arc. It's probably okay, but just be careful first. Okay, that was the end point of the little section, not the arc. So let's see what happens. Now after this 6 point, I need to turn on the midpoint because I want to pick the midpoint of this and turn the end point off. Sometimes you can even turn this off, but just let it be like this. So first you pick this point. It might not be perfectly at 50%. You can type in 50% and hit enter, and type in your radius, which is 0.2 inch, and hit enter. See how this is a smooth transition between the smaller radius and the bigger radius. And of course you can make it bigger. So 0.2 is the one I found that's, that looks okay. I think if you make it even bigger, it doesn't matter also. Okay, so that's this point. Then let's pick another point here, And as you can see, the radius is remembered from the last one, and the location you have to type in by hand. It's a percentage of your arc length, 50%. Okay, and then this edge also 50%. Hit enter, and that's all for this variable edge blend, variable radius edge blend. If you click OK, see how that edge is. It looks okay. Okay. Then the last, that's pretty simple, and you should know how to make it. How do it all the way to the end. So extrude, you have 3 holes. Okay, and I'll pick connected curve. That's fine. I can hide this extrude so I will not pick up anything weird on the surface of that solid. So that's it, and we want subject from the body, which we just hidden. Now we want to show this. Okay, subject from this one, right? Okay, and click OK. That's the holes. And if we look at the folder, the inside, this one is actually pretty round up, and that's another edge blend. And the thickness of this is 0.15 inch because we define that in the shell. So if you want to make this 180-degree arc on the cross section, you should use a half of the thickness as your edge blend, then blend the top and the bottom simultaneously. Well, looks this is did I hit enter? No, I didn't. So you have to hit enter to make this value to effect. Now if you take a look, that's actually a hole around the corner. So that's only one face here. You don't see any isoline in the middle. So that's why we need it to use a half of the thickness as your radius. Okay, so that's all for this Dolly body. Thank you.